comes from the documentation. If you're ever stuck, hover over a block and we'll click and mouse over to this C examples. C examples. This is called the documentation, otherwise known as the manual. We're going to borrow this star code. As you've noticed with assignment 2 for national flags, that stars are really common features in countries' flags. So I borrowed it right here, and let's say we run it, and there's a big star in the middle. Some of us have noticed that we can actually divide in here. And let's say, and then it turns into a division block. Notice that red part? That's under the math function. You can make the computer do all these calculations for you. Computers are really good at doing that and repeating it. And let's say I wanted a star that was half as big. So I'm adding to all these numbers, also more formally known as arguments to this block, changing all these numbers, and I'm dividing by 2. And when I finish, you should see a star that got smaller. But there's also kind of like a side effect that we didn't really want. It shrinks in size, but also moves in position. Okay, so, phew, so it goes there. And let me just have my reference one. So to make that change even more obvious, I'm going to borrow again the original star code. So I'm copy and pasting this line. Notice I also copy with the comment. I go to show text. This is where I'll do the pasting. Okay, draw, and then I'm going to add on draw a star. Just for reference, original star. And this is the smaller star. Reset. We notice over here that there's the big star in the center, and then I wanted something smaller, all right? And then it shrunk based on your origin, which is up here, all right? That's part of what I want, but let's say I wanted to move its position, and I want you to think back to your math classes where you studied translations, whether that's in Algebra 1 with lines, with slopes and y-intercepts, whether that's in geometry with, I guess, more lines, and in different kinds of shapes, and then Algebra 2 with parabolas and other more complicated functions. Okay, right now think about this as like changing the slope, changing the rate of change, and you notice it decreased in size, right? Let's say we wanted to shift it over, all these x coordinates over to the right. That's increasing for the x. I don't want to do all that addition myself. So let's say for these x coordinates, since they come in pairs, this is, for example, one of the points. Like this, what I've highlighted here is the first point, which is like, I think, this point up here. And then you should have noticed so far when you draw shapes that they go, I think, clockwise or something, like in that order, maybe. So I'm going to add 100 to all the x coordinates. And notice that I'm not doing the calculation by hand. I'm making the computer do it. So I'm writing over here, now I have 100 slash, which stands for division, plus 100. And I should see, if I add that 100, the star should move over. And this is the act of translation. It's like that y or x-intercept kind of change. One-dimensional change. And I want to leverage your math knowledge. So every other one, I'm going to add 100 to it. And the net result should be a star that shifts over to the right. And this is a handy way of thinking I want to show you, so you can do so for your assignments too. Every other point, I'm going to add 100, add 100, and add 100. Your code follows order of operations, so it's always okay to have extra parentheses. Notice that change. The star went from this position over 1. Handy. If you wanted to move it down now, what do you think we would do? Yep, I'm glad you all, the voices that I heard said subtract. Remember, we start up here in the origin, that's 0, 0, and it's all positive going down. Right? It's not like in math class. That's the weird part. With computer graphics, it's origins in the upper left, and all the coordinates are positive. So it's good that you all said subtraction. So then I'm looking at every other one. When I subtract 100 from these y coordinates, it should move up 100 pixels or so. 100, and lastly, 100. Reset. And yeah, it did move exactly up. Key takeaways from here. You can enter in these mathematical expressions as your arguments. You don't have to do the calculations yourself. Computers are really good at doing that, so make it do it. Any questions related to dilations, which is like changing the slope, or translations? No? All right. So that concludes this little talking at you, and I'll have a practice quiz question up soon, and I'll make another video.